our video for solving addition and subtraction inequalities. Our learning target is students can solve addition and subtraction inverse operations. So similar to solving equations, we're going to be using our inverse operations to answer these questions. Make sure you write down your heading, make sure you write down your learning target. If you need to pause, go ahead. Otherwise, I'm going to be going on to the first example. Okay, in example 1, we're just going to check a solution. Okay, so we're going to use that by substituting. So if I ask you y minus 5 is greater than 15, if I tell you that y equals 10, is that a correct solution, yes or no? So you have to check to see if it is. So these are yes/no questions. So I substitute the 10 in for the y, because that's what y equals, and I see if it's a true or false statement. 10 minus 5 is greater than 15. Add those, or subtract those, I get 5 is greater than 15. Is 5 greater than 15, yes or no? The answer is no. So 10 is not a solution of that inequality, because if you substitute 10 in for y, it does not give you a true statement. So 10 is not a solution. A solution that gives you a true statement. Let's check B. So I'm going to plug 8 in for x. 8 plus 23 is less than 35. 8 plus 23 is 31. Is 31 less than 35? Yes. So that means 8 is a solution. Okay? A solution is a number that makes the statement true. In this case, our inequality, if I substitute 8 in for x, that makes it true because my final result of 8 plus 23 is 31. That is a number that when added to 23 remains less than 35. Okay? So that's how you can check your solutions, and that's going to help us when we get to our graphing. Okay? If you need to pause, go ahead. Otherwise, I'm going to move on to our next example. Okay, in example 2, solving subtraction inequalities. Y minus 20 is greater than or equal to 12. That's a greater than or equal to symbol in between them. You need to start to recognize those symbols. We're going to solve it the same way we solved equations. Okay, you're subtracting, here's our variable, and we're subtracting. So the inverse operation of subtracting is to add. So I'm going to add 20 to both sides. That's going to give me y is greater than or equal to 32. 12 plus 20 is 32. 32 minus 20 is 12. You can check your work by substituting it in and making sure that it equals that amount. Now we're going to graph our answer. When we graph our answer, I'm going to put a couple tick marks on there. Okay, and make sure 32 is on there. So I'm going to do 30, 31, 32, 33, and 34. Notice that I am graphing this. Okay, I'm not graphing the original numbers in the problem, I'm graphing my solution. Y is greater than or equal to 32. What I graph is I want to graph and shade in all of the answers that make this statement true. Y are all the numbers that I can substitute in for. Okay, so I'm going to circle a 32, and I fill it in because it's got the equal to part. Okay, now I want to fill in all the numbers that make it true. Y has to be greater than 32. Is 31 greater than 32? No. What about 33? Is 33 greater than 32? Yes. So that is the direction that I want to shade in. I have now shaded in all the answers that make this true. I need to put an arrowhead because it extends beyond 34. 35, 36, it extends beyond that. All of those numbers are what make that statement true. That includes decimals like 32.5, 33 and a third, all fractions, decimals, all those are included between the whole amounts. Okay? For B, x minus 13 is less than 25. I'm going to add 13 to both sides. That's going to give me x is less than 38. 38 minus 13 is 25. I'm going to graph x is less than 38. So I'll put a couple tick marks on there. 37, 38, 39. I circle 38. I do not fill it in because it does not have the equal to part. It's just less than. So 38 is a correct answer. 38 is less than 38 is false. Now I'm going to check. Is 37 less than 38? Yes. So that's the direction that I want to shade. Is 39 less than 38? No. Okay, so I do not want to shade that way. Okay, so that's how I want to solve them like we did for our equations, and then graphing them like we did it the other day. If you need to pause, go ahead. Otherwise, I'm going to go on to my next example. Okay, example 3, solving addition equations. So this time we're adding in the problem, so the inverse operation is to subtract. So for A, I'm going to subtract 8 from both sides, and I get y is greater than 32. So now we graph that. Put a couple tick marks on there. I'm going to do 31, 32, 33. I just have to make sure 32 is on my graph. Circle 32. I do not fill it in because it does not have the equal to part, and I want to shade in. This represents what I'm shading in. I want to shade in the numbers greater than 32. Is 31 greater than 32? No. Is 33 greater than 32? Yes. So that's the direction that I want to shade. Alright, B. X plus 21 is less than or equal to 38. Subtract 21 from both sides. So that gives me X is less than or equal to 38 minus 21 is 17. So I get X is less than or equal to 17. Now I'm going to graph it. Okay, I'm going to circle 17. I am going to fill it in this time because I have the equal to bar. So it's included in the list. The equal to bar says it's included. Okay, now I'm going to shade in the numbers less than 17. Is 16 less than 17? Yes. Is 18 less than 17? No. So I want to shade in towards the 16. Again, I'm shading in all the numbers that make my solution true. If I plug in 16, 16 plus 21 is 37, which is less than 38. So that's a true statement. Okay, if you need to watch anything again, go ahead. Otherwise, I'll see you guys later.